Good afternoon, class 10th. I hope all of you are doing well and you have understood the first chapter thoroughly and completed your notes. So now we'll be doing the rest of the questions in today's class from your NCRT book. So let's get started. Okay, so this is your in-text question at the end of the chapter. Why does the color of copper sulfate solution change when an iron nail is dipped in it? And the answer is you've done this activity at the starting of the chapter. When an iron nail is placed in a copper sulfate solution, the iron displaces copper from copper sulfate solution, forming iron sulfate, which is green in color. That is, your Fe solid plus CuSO4 gives you FeSO4 aqueous plus Cu copper. Therefore, the blue color of copper sulfate solution fades and green color appears. Write this answer. Next question. You can keep on pausing the video to write your answers. Give an example of double displacement reaction other than the activity that I showed you. So, the answer is sodium carbonate reacts with calcium chloride to form calcium carbonate and sodium chloride. Na2CO3 aqueous plus CaCl2 gives CaCO3 plus NaCl. There are a lot of double displacement examples. You can write any of them. I just given you one of them. Okay. So this is an example of a double displacement reaction. Any reaction that you saw is correct. There is no wrong answers in this. Don't worry about that. Okay, so a lot of examples you've studied, you can write any one of them. Okay, now in this question, I've not given you the answer. I want you to think of the answer on your own. So let's do it right now. Identify the substances that are oxidized and the substances that are reduced in the following reactions. Okay, so the first question is Na plus O gives Na2O. They have balanced it. So now look at the reaction. Sodium is gaining an oxygen, right? So Na is getting oxidized, okay, in the reaction. And oxygen was O2 and it lost one O. So think about it like that. So that oxygen is getting reduced. So Na is getting oxidized and O2 is getting reduced because O2 lost one O there and became single O there. Okay. Now in the second reaction, CuO plus H2 gives Cu plus H2O. There, CuO is losing an oxygen and becoming copper. So CuO is getting, you are correct, reduced. And H2 gained an oxygen. So that is why H2 is getting oxidized. So like this, you will have to identify reactions. Okay, so here we'll start with your NCRT exercise questions. Okay, so you have to write them down neatly and cleanly in your copy. So the first question is identify the statements. Okay, which of the statements about the reaction below are incorrect? Now, in these, without reading the options, understand the question. What is given? PbO plus C gives Pb plus CO2. Okay, so PbO, that is your lead oxide, is losing an oxygen, right, and becoming Pb. So PbO, that is lead oxide, is getting reduced. So lead oxide is getting reduced is option D. So option that becomes correct. And then again C, that is carbon, is gaining oxygen. So your carbon is getting oxidized. Okay. So hence the again C is also correct. Therefore the correct options are third and C and D. The question is which are the incorrect ones. So the incorrect ones are A and B automatically. So like that, try to identify your question. So your option is 1, that is A and B. Okay. Those are the incorrect options. Next question. Fe2O3 plus 2Al gives Al2O3 plus Fe. Now, which the above reaction is an example of which one? Combination, double displacement, decomposition, or displacement. So look at the reaction. There was Fe2O3, a compound, and aluminium, one element metal. Now this aluminium has replaced the Fe and Fe has gone free. So this was the type of a single displacement reaction or displacement reaction. So your correct option in this question is D. The given reaction is an example of displacement reaction. Okay, Now for the next question, what happens when dilute hydrochloric acid is added to iron fillings? Take the correct answer. So what will be your reaction? Think about it. Iron is Fe, hydrochloric acid is HCl. When you are adding Fe plus HCl, you get iron chloride plus H2. Hydrogen is removed. So hydrogen gas is produced and iron chloride is produced. Okay, so your correct answer here would be which one? Option A. Okay, FeCl3 is produced and hydrogen gas is evolved. The next question, translate the following statements into chemical equations and then balance them. So first you have to identify correctly the formula also. First one, hydrogen gas combines with nitrogen to form ammonia. So hydrogen gas is H2, nitrogen is N2. So you got H2 plus N2 to form ammonia. So the product is ammonia. So that means ammonia is NH3. So you have your equation H2 plus N2 gives NH3. Balance it on your own. Try balancing on your own without looking at the answer. Second one, hydrogen sulfide gas burns in air. Now if you remember, I told you hydrogen sulfide is H2S and burns in air means you will have to add oxygen. That is the addition of O2. H2S plus O2. Now that gives you H2O plus SO2 and you balance the reaction on your own. Next one, barium chloride reacts with aluminium sulfate to give aluminium chloride and a precipitate of barium sulfate. So see, barium chloride and aluminium sulfate are both aqueous, that is BaCl2 and Al2SO4 whole thrice, and then they give you aluminium chloride and barium sulfate. Okay, and barium sulfate is your precipitate. Balance it. Try balancing on your own, it will be really good for you. Okay, next one, potassium metal reacts with water to give potassium hydroxide and hydrogen gas. Here potassium metal is a simple K reacting with water H2O, potassium hydroxide KOH and hydrogen gas H2. Alright, again try the balancing on your own. Question number 6. Balance the following chemical equations. Now here again I have not provided you the answers of balancing. You will be doing this on your own. First one is HNO3, nitric acid plus calcium hydroxide CaOH whole twice gives calcium nitrate CaNO3 whole twice plus H2O, water. So balance it. Second one, NaOH sodium hydroxide plus H2SO4 sulfuric acid gives Na2SO4 sodium sulfate plus H2O, water. Third one, NaCl sodium chloride plus AgNO3 silver nitrate gives AgCl plus NaNO3 silver chloride plus sodium nitrate. Balance it. Last one, barium chloride plus H2SO4 gives barium sulfate plus hydrochloric acid. Now you try balancing these also on your own. Okay, so that will be more beneficial to you if you balance it on your own. All of these, almost all of them we have done. If not, you can balance it on your own, and if you have any doubts then you can ask me in the group also. Okay, this is also another balancing question. Calcium hydroxide plus CO2 gives calcium carbonate plus water. Then zinc plus silver nitrate gives zinc nitrate plus silver. Then aluminium plus copper chloride gives aluminium chloride plus copper. Then barium chloride plus potassium sulfate gives barium sulfate plus potassium chloride. In this, look at the third one. Al plus CuCl2 gives AlCl3 plus Cu, the third reaction. Just look at it quickly. Now see, in this balancing, first of all you can start off with balancing what? Your chlorine. AlCl3, it was 3, so you make it even, put it 2. Then you have 6 chlorine. So on this side you have to put 3 Cl2. That becomes 6. Start by balancing that. Then you can balance the other two elements. The elements you can always balance in the end. Try balancing the larger compounds first. Okay. So try balancing it on your own, and if not, you can look at your answers. Next question. Write the balanced chemical equation for the following and identify the type of reaction in each case. Another balancing question. Okay, now here you have to identify also which reaction it is. After doing this question, you can visit the previous questions and also try and identify which type of reactions they are. It will be good practice for you. So the first one is potassium bromide plus barium iodide gives potassium iodide plus barium bromide. Now here, this is an example clearly of double displacement reaction. Next one, zinc carbonate plus gives zinc oxide plus carbon dioxide. Now this happens on heating, okay, when you heat it. So this is an example of decomposition reaction. Also on the top of the arrow mark, you can make this simple for heat in this reaction. The third one is hydrogen plus chlorine gives hydrogen chloride. That is your H2 plus Cl2 gives HCl. This is an example of two elements combining together, so it is a combination reaction. And the fourth one, magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen gas. This is an example of, you see magnesium is displacing hydrogen and taking its place, so it is an example of displacement reaction. Balance these reactions on your own. Okay, it will be good practice. Next question. We have done this in the first video. What does one mean by exothermic and endothermic reactions? Give examples. So the chemical reactions that release energy in the form of heat, light or sound are called exothermic reactions. And mixture of sodium and chlorine to yield table salt. This is a simple example. So sodium plus Cl2 gives NaCl plus some energy or heat is evolved. Then we'll come to endothermic. Those are reactions that absorb the energy or require energy in order to proceed are called endothermic reactions. So for example, in the process of photosynthesis, plants use the energy from the sun to convert carbon dioxide and water to glucose and oxygen. Any example of exothermic and endothermic will be fine. You can write any example that you want to hear. It's fine. Make sure you know at least 2 to 3 examples for each type. Next question. Why is respiration considered an exothermic reaction? Explain. So we did this before also. So the answer is energy is required to support life. So energy in our body is obtained from the food we eat. Then during digestion, large molecules of food are broken down into simpler substances such as glucose. Now glucose combines with the oxygen in the cells and provides energy. The special name of this combustion reaction is called your respiration reaction. Since energy is released in the whole process, it is an exothermic process. So your glucose takes the oxygen that you breathe in, converts it into carbon dioxide, water and energy. Water and energy you use and carbon dioxide you expel out. Next question. You can keep on pausing the slides, okay? Why a decomposition reaction called the opposite of combination reaction, and write equations for these reactions both. So you have to write for both. So give the definition of decomposition. They are reactions in which a compound breaks down to form two or more substances. And these reactions require a source of energy. Thus, they are the exact opposite of combination reaction in which two or more substances combine to give a new substance with release of energy. Okay. So in combination reaction, two substances combine and energy is released generally, and in decomposition, a substance uses energy and breaks down into two or more components. So it's the exact opposite. So any two examples you can write. Here I've given you the simplest example of water only, of water both breaking down and combining to form water. So the next question, write one equation each for decomposition reactions where energy is supplied in the form of heat, light or electricity. Okay, so for each of these you have to give one example. So first one is thermal decomposition, that is for your heat. So one example is ferrous sulfate FeSO4 takes heat and breaks down into Fe2O3, that is your ferric oxide, plus sulfur dioxide plus sulfur trioxide. We saw this example in decomposition. Then for second one, decomposition by light, you have the example of silver chloride, AgCl. So that in presence of simple light, it breaks down into silver and chloride. Silver is Ag and chlorine is Cl2. Balance these equations on your own again. Next one, decomposition by electricity. So for electricity, we have studied a few examples, water and aluminium oxide. So aluminium oxide, Al2O3 in aqueous state, you pass electricity through it, you get aluminium and oxygen. Okay, so these are your three examples of decomposition for heat, light and electricity. Okay, next question, you have to differentiate between displacement and double displacement reactions and write the equation for these reactions. So the main equations, okay. So now you can see in displacement reaction, a more reactive element replaces a less reactive element from the compound. So like we did in the video also, A plus any Bx or Bc, whatever letter is comfortable to you, you can use, gives you Ax plus B, right? So where A is more reactive than B, that's why it has displaced B. In double displacement reaction, two atoms or a group of atoms switch places to form new compounds. So that is your AB plus CD gives your AD plus CB. Same displacement and double displacement, we have done this. Then any one example for each. For displacement, you can take your copper sulfate plus zinc gives zinc sulfate plus copper, and for double displacement you can take sodium sulfate plus barium chloride gives you barium sulfate plus sodium chloride. Balance the equations. Okay, in this you can ignore the part in the middle where the page number is written. So the next question is, in the refining of silver, the recovery of silver from silver nitrate solution involved displacement of copper metal. Write down the reaction involved. So this is a process how you refine silver. That is, refining means purifying it. Third chapter you will be studying in extents of this refining of silver. So the equation is AgNO3, that is your silver nitrate, plus copper gives you copper nitrate plus Ag. Remember these equations now, because in the upcoming chapters also these will be useful to you. Okay. So silver nitrate is AgNO3 and copper nitrate is CuNO3 whole twice. And then balance the equation. Next question. What do you mean by a precipitation reaction? Explain by giving examples of precipitation. So here in this type of questions, you have to give at least 2 to 3 examples. Okay, here I've given 2. If you know one more, you can write on your own. So a reaction in which an insoluble solid called precipitate is formed and is called a precipitation reaction. For example, sodium carbonate plus calcium chloride gives you calcium carbonate plus sodium chloride. Here the precipitate is calcium carbonate. Then another example is sodium sulfate plus barium chloride gives you barium sulfate plus sodium chloride, and barium sulfate is your precipitate in this reaction. Any other reactions that we have done can also be used wherever you can see a solid being obtained and two aqueous solutions reacting together. There you can write that it is an example of precipitation reaction. All right. Explain the following in terms of gain or loss of oxygen with 2 examples each. Okay, so you have to explain using only the definition of oxygen. The first one is oxidation. So in what happens in oxidation? Gain of oxygen takes place. So simply you will write gain of oxygen and you give an example. Now see, for example, CO2 plus H2 gives CO plus H2O. So here hydrogen gained an oxygen. So that becomes your oxidation reaction. Okay. Now another example is copper plus oxygen gives you copper oxide. So here copper gained an oxygen. So that is again oxidation. So you have to explain only using the terms of oxygen. So only those valid examples can be given. Next one. Next one was your reduction. So on the top you can see reduction is the loss of oxygen. So here CO2 plus H2 gives CO plus H2O. Now in this CO2 has lost one oxygen and it is becoming CO. So you see CO2 is CO. So that is why this is an example of reduction using the words of oxygen. Next one, copper oxide plus hydrogen gives you Cu plus H2O, same reaction. Here copper oxide has lost one oxygen and it is giving you Cu. So here loss of oxygen has taken place. So copper oxide here is getting reduced to Cu. Okay. The next one, a shiny brown colored element X on heating in air becomes black in color. Name that element X and black colored compound formed. So brown colored element that you have seen, you will also be doing in your lab, is your copper. Okay. So your X is copper, and the black colored compound, so copper while heating on air, that is Cu plus O2, gives you CuO. You have studied this reaction, so that is your copper oxide, the black colored compound. So that is your answer. You have to give the reaction and balance it. Now the next question, why do we apply paint on iron articles? So remember we studied in prevention of rusting, painting. So iron articles are painted because it prevents them from rusting. When painted, the contact of iron articles from moisture and air is cut off. Hence rusting is prevented, and their presence is essential for rusting to take place. That is, moisture is essential for rusting to take place. Okay. I hope all of you are writing in your copies. Okay. Last few questions. Oil and fat containing food items are flushed with nitrogen. Why? The answer is, we have studied in the topic of rancidity, nitrogen is an inert gas and it does not easily react with these substances. On the other hand, oxygen reacts with food substances and makes them rancid. Thus, bags used in packing food items are flushed with nitrogen gas to remove oxygen inside the pack. Okay, flushing is you pass a lot of nitrogen gas through them and then you seal it. When oxygen is not present inside the pack, rancidity of oil and fat containing food items is avoided. So in the last question, it's kind of a differentiation question between corrosion and rancidity. So explain the following terms with one example each. So the first one, corrosion. Corrosion is defined as a process where materials, usually metals, deteriorate as a result of a chemical reaction with air, moisture, chemicals, etc. Instead of deteriorate, you can also write get spoiled as a result of chemical reaction. Now, for example, you can always take the most obvious example for corrosion, and that is rusting. So, iron in the presence of moisture reacts with oxygen to form hydrated iron oxide, that is Fe plus O2 plus H2O. So, again, air is O2, moisture is water, and XH2O or NH2O, whatever variable you want to take, Fe plus O2 plus H2O gives Fe2O3 dot XH2O or NH2O. That is your hydrated iron oxide. This hydrated iron oxide is called rust. And then you balance the equation, 4Fe plus 3O2 plus NH2O gives 2Fe2O3 dot NH2O. Okay. Now for rancidity, the process of oxidation of fats and oils that can easily be noticed by the change in taste and smell is called rancidity. So the fats and oils in food get oxidized. Now, for example, the taste of smell of butter changes when kept for very long, butter gets spoiled. Rancidity, how to avoid it? It can be avoided by one, storing food in airtight containers, or storing in refrigerators, or adding antioxidants, or storing food in an environment of nitrogen. So other methods also which you can write if they are correct for rancidity. So today we finished off the exercises and the in-text questions of your NCERT book. Now in the next class we will be exploring more of other questions from board papers and some of your exemplar questions from this chapter, and with that we will finish off the chapter. So your first chapter will be over. Make sure your notes are all complete, everything you've written down neatly and cleanly in your copy. Make use of this time to finish your notes easily, so that in class we don't have to focus on the notes and we can focus on your studying and your doubts. And if you still have any doubts from this chapter, contact me on WhatsApp group. All of you have my number. Okay, so you can contact me there and ask me any doubts regarding to this chapter. Okay, so take care. See you in the next class.